So we're starting with the first problem on the review problems. So you start 2 sine theta equals 1 by dividing each side by 2. You get sine of theta is equal to 1/2. Then you look on your unit circle and you find out that sine of theta is equal to 1/2 when theta is 30 degrees or 150 degrees. In the second problem, I didn't want you to make it harder than it was because it's already factored for you. So you let each factor equal 0 using the property of zero products, and then you solve each of those. So over here, 2 cosine x equals -1. Divide both sides by 2. So cosine x equals -1/2. And so cosine x is equal to -1/2 at 120 degrees and 240 degrees. Over here, solving, we get sine of x is equal to 1, and that happens whenever x is equal to 90 degrees. So on this problem, our answers were 120, 240, and 90. In problem number 3, this one you will need to factor. I'm going to go ahead and factor out the GCF, which is 2. So then I'm left with 2 cosine squared x plus 3 cosine x plus 1 equals 0. So then I'm going to factor that trinomial into 2 binomials. So I would get 2 cosine x plus 1 times cosine x plus 1. Let that equal 0. And then you let each factor equal 0. Now we ignore the 2 because that can't ever equal 0. So we take cosine x plus 1, we let that equal 0, and cosine x plus 1 equals 0. So solving this one, you get cosine x equals -1/2. And so the answers are the same as the last problem, 120 and 240. Solving this other equation, we get cosine x equals -1, and that happens when x is 180 degrees. So our answers are 120, 240, and 180. All right, so today what we're working on is solving trigonometric equations with answers that aren't on the unit circle. So our first example is 4 sine theta minus 3 equals 0. We're going to solve that just like we did the first one in the review problems. That's how we'll start it. We'll say 4 sine theta is equal to 3. And so then we get that sine theta is equal to 3/4. All right, but that is not on your unit circle. So what you guys are going to do is you're going to take the arc sine of each side. And so then that undoes the sine function there. And so we get theta on the left side. And when you do second sine, 3 divided by 4, or 0.75, you get 48.6 degrees. All right, so the calculator gave us one answer that's between 0 and 360 degrees. But there are other answers as well, because if you look back at the first review problem where we had sine theta equals 1/2, we got 30 degrees out and we got 150 degrees out. So thinking about this, on the unit circle, the calculator gave us our reference angle of 48.6 degrees. And the sine was positive. So there's another angle on the unit circle that also has a sine equaling a positive 3/4. And so from all students take classes, we know that that angle is going to be in quadrant 2 because sine is also positive in quadrant 2. So it gave us a reference angle of 48.6 when we did this. So I'm going to go ahead and redraw that for you. So the reference angle was 48.6. And so now we want to know the value of the angle in standard position. And so that starts here on the x-axis in the positive direction. And then it goes to where the terminal ray is. So to figure out this problem, it's going to be 180 minus 48.6 degrees to get that angle. And when you do that, you get 131.4 degrees. So this problem has 2 answers. It has the 48.6 that was originally given to us, and it's 131.4 degrees. Okay, because today we're putting we need all of the angles that satisfy the equation that are between 0 degrees, and 360 degrees. So that's example number 1. In example 2, we have 2 cosine theta minus 5 equals 3 cosine theta minus 2. So we're going to go ahead and we're going to start by getting all the variables on one side and all the constants on the other. So when I do that, I have negative cosine theta is equal to 3. So cosine theta equals negative 3. So if you were to say that cosine theta is equal to, or that theta is equal to the arc cosine of negative 3, on your calculator, that should give you an error, right? And the reason that it gives you an error is right here. We know that cosine must be between negative 1 and positive 1. And so when you get a cosine outside of that range, that's undefined. So as far as this problem goes, there is no solution. There are no values of theta that give you an answer to that equation. Okay, problem 3 is the tangent problem. So we're going to start by isolating the variable. So we add 5 to each side, and we get 2 tangent theta is equal to 5. Dividing both sides by 2, we get tangent theta is equal to 5 halves. And then you guys would take the arctangent of each side. And your calculator would give you a result of 68.2 degrees. All right, now we already know that there is going to be 2 answers on the unit circle where this happens. So 68.2 is our reference angle given to us by the calculator. So thinking about this, all students take classes. Tangent here was positive. So the first angle that was given to us was here in quadrant 1. Our next angle is going to be in quadrant 3. That's the other place where tangent is positive. So the reference angle is 68.2 degrees. So now we have to figure out what the angle in standard position is. So I start here, I go 90, 180, and then I have to go 68.2 more. So that second angle is going to be 180 plus 68.2 degrees. And when you do that, you get 248.2. So our 2 answers then are 68.2 and 248.2 degrees.